Hello there, welcome to the A-Level Maths Pure Paper 1 of June 2023. Here we're looking at question 12. We have y equals sine of x, where x is measured in radians. Use differentiation from first principles to show that dy by dx is cos x. And you may assume that as h tends towards 0, sine h over h is 1, and cos h minus 1 over h tends towards 0. So let's remind ourselves of what the definition of a derivative is. It is the limit, it's in the formula booklet if you've forgotten it, the limit as h tends towards 0 of f of x plus h minus f of x all over h. So let's apply this derivative definition to the sine f of x, the sine x function. So it's the limit as h tends towards 0 of sine x plus h minus sine x all over h. The next thing we're going to do is break apart this sine x plus h by using the angle addition formulae. So that's going to become sine x cos h and cos x sine h minus sine x all over h. Okay, in the next line, I'm going to split the first part and the third part into one fraction and the second part of the numerator into a second fraction. The reason I'm going to do that is the first term in the numerator and the third term in the numerator both have sine x in it, so I can factorize sine x. In the first term, sine x multiplies by cos h in the brackets. And in the third term, it needs to be a minus 1 in the brackets there. That's all going to be over our common denominator of h. And then add the second term on top of a fresh new fraction, cos x sine h over h. Now we apply these rules here. So on the first one, cos h minus 1 over h, that will tend towards 0. So as we take the limit as h tends towards 0, this part will tend towards 0. So sine x times 0, let's write this down, limit as h tends towards 0. We're going to have sine x multiply, actually no, we don't need the limit at this part, we're taking the limit, sine x will be multiplied by 0, and cos x will be multiplied by sine h over h tends towards 1, so it's going to be cos x times 1, which is now equal to cos x. And there we are, that's the answer for this 5-mark question 12. Let's now move on to question 13.